This is Quideo number 3 with the basic question here. A, the mean of a population proportion equals the proportion, which is given as 0.40 in the equation, and the standard deviation is the square root of PQ over N, which in this is 0.40 times 0.60 over 1785, and that's square rooted, which is 0.116. For B, the sample population is less than 10% of the adult population, and that's rule of thumb number 1. You can use the formula for standard deviation. For C, rule of thumb 2 just says n times p is greater than or equal to 10, and n times 1 minus p is also greater than or equal to 10, and both of those are found to be true based on the two equations I have. For part D of the basic question, we need to find the probability that p hat takes value between 0.37 and 0.43 for our equation, or for our formula. So we take the z-score of 0.37, and we find that to be negative 2.59, and we take the z-score of 0.43, and we find that to be 2.59, and those values, the probability of getting those, is 0.9952 minus 0.0048 for each, and then those subtracted gives you 0.9904, meaning that 99.04% of samples of 1,785 will give p hat within 3 percentage points of the true proportion. For the advanced question, part A, we need to find a confidence interval. So that equation is mean plus or minus z-score times standard deviation over the square root of n. And for that is, for our equation, that is the confidence interval equals 4.5563 plus or minus 1.96, which is the value for z star for 95% confidence, and then times 3.1231 over the square root of 16. And I found those by putting in the differences into the calculator and finding the mean and standard deviation. And then that will give us 4.5563 plus or minus 1.5303, which means the confidence interval is from 3.0260 to 6.0866. And including part B, we're 95% confident that the mean difference is between 3.0260 and 6.0866, meaning we can say with 95% confidence that there is a difference between the methods used. For the AP question, part A, we have a normal distribution with a mean of 288 and a standard deviation of 2.8, and to find a z-score, or we're going to need to find a z-score for the probability that a ball will travel too far, which means we'll need to find the z-score for 291.2 yards. So we use the equation given right here, z equals the sample minus the mean over standard deviation, and then when we plug in the values that we have, we end up with 1.14. So we need to find the probability that z is greater than or equal to 1.14, and we were able to do this by looking at the graph, or table A, which gives us 0.8729 for z of 1.14, and then we take 1 minus that value to give us 0.1271 for our answer. For part B of the AP question, we need to find the probability that at least one exceeds. So we'll use 1 minus the probability that none exceeds to the 5th power. And we can find this value from part A up here. The probability that 1 exceeds equals 1 minus the probability that doesn't exceed. And the probability that 1 doesn't exceed is right here, it's 0.1271. So the probability that 1 does exceed is 0.8729. So when we plug this into the equation right here, we get 1 minus 0.8729 to the 5th power, and then we end up with 1 minus 0.5068, and we get an answer of 0.4932. For part C of the AP question, we need to find, or we go to table A, and we find where 99% certainty can be found. So the probability that Z is less than 0.2 or 2.33 equals 0.9901. So that's the lowest value we get while still being 99% confident. So we put in that Z-score into the equation for Z-score. Z equals the statistic minus the mean over the standard deviation, which is right there. 2.33 equals 2.91 or 291.2 minus the mean over 2.8. And we can go over here and we can manipulate the equation by multiplying 2.8 on each side and getting it over to the left. And then we continue manipulating the equation by adding the mean on both sides and subtracting the value we received by multiplying 2.8 and 2.33. And then we end up getting a mean of 284.676. So to be 99% certain that a randomly selected ball will not exceed 291.2 yards, the largest mean that the ball can be hit has to be 284.676 yards.